Hey everyone, welcome to this ETHCluj online meetup. We have a very interesting topic for today, but before I pass on the mic to our speaker, I want to tell a few words. We're working to maintain a constant pace to bring more speakers with interesting subjects. And so stay tuned for other meetups that will be announced soon. We have also decided to distribute pop-ups, or how you pronounce it. So to those, so if you attend ETHCluj meetups, you have the option or have the opportunity to get a pop-up, and I'll explain what these are useful for. So they are part of Road to ETHCluj series, and as Road to ETHCluj has been recently announced on our social channels. And the idea is that you can redeem or mint the PWAP to get ticket discounts to ETHCluj conference. And the conference will take place at the end of June. So for those who haven't used PWAPs before, basically these are NFTs that you can mint to have a proof in your wallet that you have attended an event. At some point during this presentation, we'll show the PWAP for this event, so you can scan it and get a discount for the ETHCluj conference. The minting is free, and you will receive the PWAP on Gnosis chain. They have some wallet abstraction things, so you don't have to have any gas in your address. And during the following meetups, which are part of the Road to ETHCluj, we'll have more PWAPs, and you can accumulate them to get more discounts for conference tickets. Each PWAP is a 25% conference ticket discount, 2 PWAPs 50%, 3 75%, and for those who collect a maximum of 4 PWAPs, you will be eligible to receive 1 free ticket to the ETHCluj conference. And Ethereum for Everyone conference organized by ETHCluj starts in June 26th. It's a 3 days conference. And if you go to ethcluj.org, you can get your tickets from here. You can apply as a speaker, sponsor, volunteer, media partner. That's another way to get into the conference. You'll see our community partners that we have announced in here. These are basically other international Ethereum clubs or Ethereum event organizers. And then you can see our first wave of speakers that have been announced so far, and there are many more to come. The conference venue is a building of the Technical University. It's basically in the center of the city. And then later you can also check out the conference tracks, which basically set the mood or the thematics of the conference. Yeah, so yeah, that's about it. So to move on, today's speaker is Pranshu. Welcome, Pranshu. Thanks for coming in to share your knowledge. So his topic is open intent framework, and he'll talk what it is about, why it's important, and what benefits can Ethereum ecosystem users expect from it. And then I assume this is a generic standard, so it probably can be adopted by other ones as well, but correct me if I'm wrong. Yeah, so so without further ado, also my screen share, Pranshu, you can share your screen, and let's kick off.
Oh, hey, hi everyone. Can you hear me? Yes?
Loud and clear.
Cool. First of all, thank you so much for, inviting me over here and giving the opportunity. And so keep tuned in because, trust me, like minting that web would be like very beneficial for you. Let's start with the screen sharing. Let me know like if you can see my screen. Can you see the slide or the screen?
Yes.
Right? Cool. So what we are going to do today and how we are going to, follow up this whole meeting is I'll just give you the glimpse of like, how we are going to continue. First of all, whenever you feel to ask anything, if my voice is not audible, if I'm moving too fast, too slow, any suggestion would be, highly appreciated over the chat. You can raise your hand. We can have a chat. The session or how I have designed this whole session is we'll go with the insight of Ethereum, then on the intent and solver and open intent framework. We also do have some demo, and we also have some, a relative example that will help you learn about this. So a very quick chat. Anyone who is here haven't heard about intent or solver, or does not know about intent and solver a lot, or even a bit? Or can you just chat, like drop a message on chat if you're not aware about intent and solver? Cool. And how many of you are, like intermediate on in terms of like in intent and solver over here? Can you raise your hand or maybe type on the chat box? I can see probably three of us. Cool. Got it. So I guess let's get started. Today's topic is open intent framework. Discover the open intent advantage. Before we start, I'll tell you, who am I? My name is Pransh Rastogi. Currently, I'm the head of ecosystem and integration at Push Protocol. Also, this is a bit about me. I have around 6+ years of experience. What I usually do is code, reading books about the blockchain and other parts, like the psychology and everything. I crack lame jokes, so bear with me. Also love to play games on PS5 and travel. So this is who am I and what I do. To get started, first thing is this is the content what we are going to learn today. This is divided into 6 basics component. Initially, we are going to start with the how Ethereum was back in 2020, and then a bit about intent solvers example, a specific ERC-7683, what it is, and why do we even need this, and a basic demo, right? So just imagine, like who are in the blockchain space from last few years. You must, or you should have realized that, back in 2020 or before 2020, Ethereum was very slow. Even the fees in the Ethereum was like around $50 to do a transaction, and it was a bit slow. Then we basically come up with a roll-up centric roadmap. If you see all this, right? We started to having few of the L2s to solve this scaling problem, right? We maybe have started with Polygon or few chains, few popular changes, but eventually we end up, having a lot of them, a lot of chains in the ecosystem. So you can see, over here by this video, we got Polygon, we got Optimism, we got Arbitrum, we got zkSync, and a lot of them. But they have solved the scaling problem, but in parallel, Ethereum become fragmented. Now, what is fragmentation? Or what is the issue? Or why do we even care about the fragmentation thing? So how many of you use MetaMask or any of the, wallets? This image is something, you are a bit usually used to it, or you have seen a lot, right? Even to a simple transaction, you have to switch to a different network, a lot of chains. And trust me, the image that I posted over here is not half of it. I still have 10, 15 more networks in the MetaMask that is important. So now you can think, previously back in 2020, when Ethereum was there, we had this issue of not scaling up, high fees and a bit slow. Then we came up with the solution, second thing, a lot of L2s. But, as we usually say, anything that is in a lot of access is most of the time bad for us, or like bad for all, right? So that happens basically even in our case, that we end up having a lot of L2s. You can see, like, in the diagram that I have posted over here, or like in the visual representation that I have posted over here, you can see, like, we are going to move a lot of assets between different L2, but this basically lead to the fragmentation and inefficiency in the user experience. For example, you have to move the Ether from Polygon to Optimism. It's not like, seamless. For example, how we usually do a transaction when we go to a grocery shop, right? We just pay. They don't care, like, whether that money is coming from ABC Bank or XYZ Bank or somewhere else. It's just tap and pay, and that's it. But over here, like, just moving the funds, if I have to stake, then maybe staking on Base giving me a different APR. Staking on Polygon will be giving me a different APR. And not only this, even one of the reason you will ask me, like, hey, Pranshu, why do we even need like a lot of L2s? Okay, that's fine. Like, why I'll use like a lot of L2s in my day-to-day life. So the reason can be that some of you might used to, mint an NFT over the Polygon because they have like a good liquidity or something like that. But some of you wanted to play games on Arbitrum, and some of you may use DeFi on Optimism or socials on Base, right? But combining all those networks to a single address is quite difficult. So this is one of the reasons that basically depicts the rise of intent. um, Before moving forward to like what is intent, or like how we usually define the intent, let's see this. Like, why don't we use bridges? I guess, like, if you are in a Web3 even for a while, you would have um, sorry, you would have heard about the bridges in the past. Okay, like, we have an intent as a solution, but why don't we use the traditional bridge flow? Okay, so let me explain you, if you are not aware, like what usually happens in the uh, bridges flow is, for example, you have asset on the blockchain A, and you have to move that asset to the blockchain B, right? So if you see over here, yeah, right now, in case, like, when we have the traditional bridges, in order to transfer the asset from the blockchain A to the blockchain B, what you have to do is you have to send the transaction to the origin chain, then wait for the finality, then the asset should be received on the destination chain. Again, like, there is a concept of finality. If the finality has not been reached, that means we cannot uh, make sure that the tokens or the asset we have in the blockchain is there for sure, right? The transaction can be reverted or anything can happen, right? And it usually take 10 to 15 minutes, even if we talk about the one blockchain, or it depends, like, which blockchain we are using. So that basically end up the spoiling or creating a lot of mess in the user experience of the end users in this case, like when we are using the traditional bridges. But the same case when it happens to the solvers, I'll tell you, like, how it basically solves the issue of bridges. But ideally, to end the issue of the user experience, we need, at least the time should be like within the frame of 2 to 3 seconds. And that can be solved with the help of intent and the solvers, right? So first of all, before, of course, diving back to the technical aspect of intent and solver that we were seeing in the previous Excel diagram, let's try to understand what are intent and solver with something or with an analogy that you usually do in your day-to-day life, right? I think one of the things that we usually use or we usually have is the GPS or the Google Maps or any kind of Apple Maps, right? So if you see this diagram over here, the whole idea of providing like the intent of us of using the Google Map is we just have to provide the source and the destination. Okay, so the by intent we implies the thing that we wanted to achieve in order to use that application. So if we are using the Google Maps or Apple Maps, the intent will be we'll be providing the source, we'll be providing the destination, and okay, you provide us the best route for the same. So if you see even in this visual, right? Now what solver is going to do is solver is going to, try to find the best optimum solution, or maybe, do some algorithm or use coordinates and everything and find the best route for us. Similarly, in the blockchain space, when we talk about the intent and solver, rather than bridges, user don't have to take care about that complexity in the usual ecosystem. They just have to provide that, hey, yeah, I have this one die, or like I have this, a 2000 die. You just give me one ether instead of this. If you wanted to take a fees out of it, for example, 5 die or 10 die, take it. But I don't have to bear the complexity of usual what happens in the bridges, like connecting the wallet, changing the networks, transferring the asset, taking care of the gas fee even. For example, if you have transferred the asset to a separate chain, but you don't have a gas fee over there to pay, then again, you are stuck. Then you have to transfer the ETH or like whatever the native gas token for that specific chain is. So we have understand by the simple example of day-to-day use is Google Map. Like what is intent, what is solver. Intent is basically a simple, a use case or simple, basically explanation of line what we wanted to do and achieve. We don't have to bear the complexity that comes behind the intent. That is the job of solver to do all the calculation or provide what is expected in the intent that we have basically seen in this visual diagram. You can see like solver has find out the best route and everything optimum, and of course provided with the locations and everything. Now this is something that we have understood in terms of a very basic analogy uh, that we usually do in our day-to-day life. Now I'm going to explain you or show you a actual Web3 demo through which you understand like what's happening in the technical space of intents. So why I'm going to break down before like telling you the definition of this or like going to the code or anything is you have the visualization picture in your mind, and then we actually go to the standards and everything you can correlate with it. So open intent framework or basically OIF has basically created this small UI or the demo for it. Right now, of course, the contracts are not audited, and it also has a cap of 50 USDC. You cannot use more than that, but that's fine for us. We just wanted to uh, do or see like how basically it happens in the intent framework as we compare to the bridges. So firstly, I'm guessing like most of you over here has uses bridges to transfer the asset from one chain to another. And I guess like I'm if you haven't, maybe like Stargate used to have that, right? A 15-minute wait time or like 10-minute wait time to transfer an asset. Now see like what's happening. For example, let's say I'm going to transfer the 2 USDC from Arbitrum to Base. Okay, this is my source chain, this is my destination chain, and as a recipient, maybe I'll provide my different address that already have the 1 USDC. Okay. Now I'll just click on continue over here. Firstly, it will ask for the because like one of the thing is I have previously provided the approval, so that's why like this is not like asking for the approval over here. So if I have to go and send it to the base, I just have to sign the intent over it, and you can see like um, although I have defined the 2 USDC, but if you see over here, the cap is 2.05. I'll tell you why, it has 2.05 cap over here. But if you see all these instructions and everything, yeah. So if you see all these instructions and everything, you'll see like how it usually happens in intended solver is, this is our sender address, this is the recipient address, okay, token address, and the destination transaction hash. That is, it is done. The whole process is done. So instead of transferring the two base to the destination address, it also provided a basic 0.05 fee to the solver, providing the support, okay, that, you are doing this transaction. And you can see like, everything happens within like frame of few seconds, for example, 5 to 10. And now we have asset transfer from the arbitrum to base. You can see like the updated balance is 3, which is unlikely in the case of bridges, what we usually have in our like, previous cases. So coming back to, the slides over here, let's understand how does intent and solver work. So previously we have talked about intent and solver in the analogy manner. Then we have seen a demo like how it actually works in the blockchain space by transferring asset from one chain to another, right? Now we are going to break it down the how intent and solver work. So always remember this basically works in the 3 parts. First is the expression, second is execution, third is settlement. Even when we are going to, see code of ERC-7683, we are going to, segregate most of the interface function into these 3 parts. And even like, most of the cases, we can segregate the whole structure into these 3 segments. That is the expression, execution, and settlement. I'll just show you or like tell you how it works. Give me a minute. So first thing is basically the intent expression. When we talk about the intent expression, that basically depicts that what user wanted to achieve. Even if you see over in here in diagram, user specify their like desired outcome on an application. Similarly, when we try to relate this with the analogy of GPS, they provided the source and destination. If you try to going to relate this with the uh, example that we have seen, so our intent was send this to USDC from Arbitrum to base. Okay. Now the execution part. In this, there can be like more than one solvers who provide the best price or best route. Okay, and once we have that route, like whosoever is the winner of the route, the auction happens. Basically, of course, like we are not going to deep dive into the auction process or like how solvers are basically competing. That is a separate process. But just to give you an insight, once the solver wins, who is going to fulfill the request, they basically initiate this transaction. And of course, this can also be a guestless that I'll show you with the help of interface. And finally, the settlement. Once everything is done, the solver is paid and the intent protocol verifies with the satisfaction. Like solvers get their extra fees, whatever they did, because they provided the liquidity to settle this transaction, right? Now I'm taking a pause and I'm also going to showcase you 2 things. Basically, what happens? See this. This is a blockchain A. This is the blockchain B. Okay. Now, why intent or solver application reduces a lot of time? Try to understand fundamentally. One of the core reason why it is taking a lot of time is this finality part in the bridges, right? If you are going to use the blockchain A and the blockchain B, the major or the complex part that usually happens is the finality thing, right? Because you have to settle the transaction to a different blockchain in the bridges thing. Now, when we have a solver in place, what will happen is, let's say you have a funds on a blockchain A, okay, and user say, okay, I wanted to transfer it to the blockchain B or anything, right? So instead of settling the transaction to the blockchain B at that specific time, what solvers do is solvers have a liquidity with themselves. Okay, so if someone is going to ask, like, okay, give me the funds, rather than settling, that is basically the complex part of the problem. They provide funds immediately to the end user, and in terms of the end user, the complexity has gone. Right now, they don't have to care, like, okay, I have to freaking wait for 15 minutes to get the finality on the another blockchain or something like that. From the end user, the complexity, the user experience, and everything is smooth. The risk, or like most of the part, the settlement part that needs to happen has to be happen from the solvers itself. And of course, they don't have the criticality of time, so they can also do it later, or like, of course, there are like a lot of things in terms of like, how they manage the risk of this, like if price goes up or down. But we are not going over there. The complex part is basically handles by the solvers itself. If I also can show you something like this, this is a basic flow. Try to maybe understand from this. This is a very, very basic flow, not a detailed one. So firstly, user initiate intent that, okay, like, I wanted to send this asset from this chain. User create cross-chain order using ERC-7683. Then, of course, broadcast via open intent framework. Now they'll see like if solvers are available. If they are not available, then wait for timeout, and this cycle happens again. If they are available, then they'll select, of course, the solver, like whatever this is best, and then solver execute the intent. Now there can be two cases, like execution either successful. If no, there will be retries depending on like how much we have defined, and of course a retry happens. If execution is successful, then settlement, the last part, because like even previously when I was showing you that diagram, there were three segment, right? And the last segment usually is last segment is settlement. So finally, the settlement contract verify ERC-7683, and user is notified of success. And if, of course, it gets fails, user basically notified it is failed and the process is complete. Okay. Now, going back to the slide itself, let's try to understand in terms of what happens or what is ERC-7683. Okay. But before this, let me show you with a diagram. Okay. For example, this is one protocol that is using the intent part, right? Or intent protocol. This is intent protocol 2, or this is intent protocol 3, right? Now imagine we don't have a standard ERC-7683 in this world, right? What will happen to this three different uh, you know, uh, intent protocol in this scenario? In this scenario, each one of this protocol will have their own independent solver network. Okay, these are their own independent solver network, and they will of course provide the same scenario. They'll provide the liquidity. They'll take the rest. They'll do everything that we are learning or talking about from last few minutes. But in the case of standard of 7683, let's say we have this three network. Now what will happen is I'll just remove this maybe very quickly. Okay, maybe I'll just draw, otherwise it will take a lot of time. Let's say we have again this three different protocols, but now what we have is ERC-7683 in the place. That is, they have a unique common pool of liquidity, right? And because of this cross-chain network, or like the cross-chain liquidity providation, it not only boosts the liquidity for the whole intent protocols that are the different protocols. For example, this is across Uniswap or someone, right? They can consume the solvers from the common pool, and it also enhances the user experience, because in the left-hand case, the chances may be like um, they don't have like this have a lot of users, but it does not have the solver liquidity, or vice versa or something. But here they can utilize the common pool, or of the liquidity and everything. So ERC-7683 is basically designed to standardize the intents and bring multiple benefit to the Ethereum ecosystem. Why? Because if every protocol is going to design their own intents and solver logic, then what will happen is, again, like, the problem that we are going to solve about the fragmentation won't be solved. Then there will be a fragmentation in terms of solver. There will be issue of liquidity. There will be an issue of interoperability. The speed of transaction will be less. And that's why this ERC standard has been proposed, which basically helps to unify the Ethereum by providing, or by basically boosting the liquidity, eliminating the fragmentation, and enhancing the user experience. Okay, so this is the reason why we have this ERC-7683 in place. Now, the most awaited topic, or the headline of this whole meeting, open intent framework, is in the place. Now try to understand what is open intent framework. So open intent framework is basically the bigger set. Okay, it is basically the modular open source framework through which you can build and deploy intents. You can have the customized logic of your solver. And of course, ERC-7683 as a standard also comes under it. Okay, so open intent framework is basically one of the initiative by EF, Across, and the Bootnode or Hyperlane. So they said, rather than fighting with each other or having creating own independent solver, let's try to create a standard modular framework through which everyone can participate into it, and of course fix all this issue that we have seen in the previous part. So we have this open intent framework that is modular, open source, and everything. I'll show you the code interface and everything. But within it, we have ERC-7683, and of course, solver may have customized logic, and through which they can also not only send the tokens, but can also be used for votes and other things. Sorry. So there are three major components that basically makes this open intent framework. One is the composable smart contracts. Second is the open source solver implementation, and third is the UI template. So the UI template that I was talking about is the demo that I've shown you, app.openintents.xyz, is basically that, right? But I'll show you where it is, what it is mean, and about all the things. But before that, let's do some code repo travel to understand this open intent, like the three segments of the open intent framework. Okay, so we'll go to this repo intent framework. First thing is, don't worry, I'll be providing all these resources and link to you later on of this call. So this is the intent framework repository. If you see this again, compose of three major things, that is the smart contracts, solvers, and the UI. Okay. If you go to the, first let's try to understand the main important topic, that is the ERC-7683 or the composable smart contract. If you see, we also have few of the smart smart contracts as an example from the Hyperlane, basic swap, and the base thing. But main thing that we are going to focus is on the interface of the ERC-7683, because this is something that you can use to create the whole intent or solver framework, right? Now, this interface contract have a lot of struct interfaces, or what we say function. But I'm not going to read each data type or function name and tell you okay what it does. Maybe I'll try to showcase you firstly by the flowchart I might have created. Okay, yeah, here it is. So firstly, try to understand from the flowchart, then we basically browse through the code itself. So first thing is user express intent. Okay, that is common in everything, right? Second is the order creation. Now, if you see the interface contract, there are two struct. First is the guestless cross-chain order. Second is the on-chain cross-chain order. Okay. Now, why we have two different struct even in the creation or initial phase? One thing is this struct specifically defines if you wanted to achieve the intent when you don't even have to pay the gas fee. For example, user don't have the gas fee and they wanted to, execute the specific intent, then this struct can be used. But in the case like, if they have the gas fee or they can pay the gas fee, then this struct basically can be used, right? Then of course, one this is done, then it will go to the I origin settler contract, which will basically resolve all these queries and everything. Resolved cross-chain order that basically outputs and fill the instruction. And finally, the destination settler and order settlement completed. Now I'll show you the same thing with the code. So this first two struct that we are talking, the guestless cross-chain order and the on-chain cross-chain order, are the two struct which are used to basically uh, 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 send the intents. If you have the guest fee, you are going to use this. This is basically, or I'll try to give you the analogy. Try to understand what is FedEx for, like, Ethereum, Polygon, or other thing, right? This is basically the post office addresses, like, the destination user addresses, amount, and everything. So similarly, like all these parameters are used, and similarly over here, then the resolve cross-chain order basically, try to fill this thing. I can showcase you with one more flowchart that I have. And these are basically the helper, the output, and the fill instruction struct. These are more of an helper thing. And finally, on the origin chain and the destination chain, these two struct can be called, that is the I origin, I origin settler and the I destination settler. So if you go back, and you can also, read this smart contract, but if we go back and go to the TypeScript, they also have provided the basic solver thing and the UI thing. The UI thing, I think we have also seen over here, like the whole concept of how this open intent framework works, right? I think I have also few of the things. Yeah, I have this one more flowchart, but I think this is more complex that we have seen over here. Like this is the basic one, but this is the more complex. If you wanted to understand in terms of what happens right now is, for example, user create signs, guestless order, submits, then it goes to the filler, the helper one, and it calls, then it emits the thing, origin settler, like the whole thing. The whole process has been I have integrated over here. I can share this with you afterwards. Coming back to the thing. So I'll do the quick review what we have learned so far so that you have everything in your mind. We have started why, when there was an issue in 2020 that Ethereum was, heavy and slow, everything. Then we come up with a solution. Okay, get L2s and fix this scaling issue. But once we started with this L2s, a lot of L2s were there and we fixed that scaling issue, huge progress. But because of that, a new problem occurred, that is the fragmentation. You can see like in your wallet, there are like a lot of L2s and everything. Then a different L2 can be used for a different use case. But of course, transferring the asset from one chain to another is very difficult. Then we came up with one solution, that is intent and solver. But previously, how we are transferring the asset was through the bridges. Okay. But why bridges has an issue is because the user experience is bad. They don't have the like transfer within a second or minute. They have like a lot of time taken to just to transfer the asset, and that is not a very user friendly experience. We try to understand what is intent and solver with an example. Also seen a demo. Basically, this has had three components: expression, execution, and settlement. With the expression, user basically provides what they want. Execution is basically they see, okay, I can provide that liquidity or not. And then finally, the settlement thing. We try to specifically see, okay, now we know what are intent and what are solver. Now, why do we even need a standard? Because if we don't have a standard, again, the fragmentation issue may come. Now we have a standard and everything. Now, wrap up all these three things like the front end, solvers, and everything, and try to create a whole framework. That's why, the open intent frameworks come into the place. And that's have like this three major component that we have even see and walk through that. So finally, what I did is I have, to be very honest, I haven't put all the resources over here. If you want, what you can do is you can scan this QR code as of now. Okay. I have just put uh, okay, what is this? I have put like a few of the resources, but maybe by tomorrow or this weekend, I'll add all the resources over here. Also, I'm thinking to create a repo to contribute in terms of like integrating all the resources at one place. But uh, I have also created a video in case you have missed few of the things. Also, I think they are recording, so you can also watch this again. And then we have like this thing, and this is a very good blog by Ada from Hyperlink. Even have learned from this a lot of things. And I'll be putting all these things into this resources. So please, try to have this, or I can also share this whole meeting presentation with you after this call. And I think this is mostly it from my side. If you want to connect with me, you can connect me over Twitter, email, Medium. Want to read like more blogs or like reach out to me? Best place is Twitter or Telegram or email. Also, do let me know like if I can assist you with anything. So these are the few ways you can connect with me. Uh, Finally, yeah, that's it from my end. Thank you so much, like ETHCluj, all the team, and all the joinees for this session. Over to you, Alex. Yeah.
Cool. Thanks, Pranshu. Thanks a lot. So, could you please leave the slide with the resources QR code until we have the questions?
Yeah, sure. Okay. So I have hosted this website. I can drop it over here.
Cool. Cool. Got it. So the first question in the chat, what mechanisms can ensure that selected solvers complete an intent? Meaning, how do you ensure satisfaction, or how do you know that an intent has been completed and the solver has done its job?
Got it. So I think, see, one of the few example is, even if you see, I have also, I think my screen is shared, right? So today I was also working in few of the examples. If you see like the basic thing. So once we create this functions, right, in the Solidity, execute intent. Usually, like once the solver, done its job, it basically emits the event that can be trapped. Otherwise, we can also have like, few of the validators. So what they will do is they'll fetch few of the latest blocks from the blockchain rather than like, archiving the whole thing, then creating a Merkle root out of it, and then basically verifies whatever the solver has done or said, whether it's true or not. So of course, like, there can be a lot of mechanism by a Merkle root or like a ZK thing, or like simply like, by reading through the event logs, you can, verify through it. But yeah, these are few things that through this it can be achieved.
Okay, cool. And for example, you showed us the demo. Do you know what so it's openintents.xyz, the
Yeah, this is app.openintents.xyz.
so
Yeah.
do you know how they work, or how do they ensure the fact that
So they basically are using, I think, Hyperlane, because this is basically, openintents.xyz by EF, and they have mentioned it somewhere else that they are using Hyperlane interface or something to use this demo. But to be very honest, I haven't went deep dive into the Hyperlane contract, how they are specifically approaching to this issue. But yeah, this demo is majorly powered by the Hyperlane itself.
Okay, got it. So that would be a good place to look into, meaning hyperlane. I mean, so what I've understood so far, that basically this is an open standard that people can choose to implement in the way that they want. So it doesn't restrict necessarily how you have to check to verify satisfaction, for example.
Yeah. So if you see the intent is standardized, but even if you see in the over here, I think somewhere they have mentioned that the solver, they give you the flexibility to customize the specific logic
Okay.
to the solver itself, right? I could not find it right now, but yeah, if you read this thing, this is I think one of the first part that we have announced. So this is the Notion page that they have shared. And of course, more than 50 plus protocols are participating into it. So they gave the flexibility to customize the logic for the solver. But again, they have standardized the intent, you can see they have standardized the intent part, so that if solver is trying to fetch the intent, they know like what is the specific standard input they have to look into.
Okay, other questions, guys?
Yeah, I have one question, please. So, Pranshu, can open intent framework be used for like cross-chain swaps or just bridging?
Yeah, so open intent framework, of course, is used for the cross-chain swaps. Even if you see the demo that I've showed you. So this is basically the cross-chain, the Arbitrum base. The whole idea is open intent framework is for the cross-chain swaps only. So how they are different from bridges is, in bridges, we have to wait for the finality. Finality can differ from blockchain to blockchain. For example, some blockchain may have 10 minutes finality. So we have to wait for 10 minutes or 15 minutes. Even if you've seen a previously Stargate or like any of the bridges, if you see, we have to wait for like 10 minutes or 15 minutes. But when I did the demo over here for like this cross-chain Arbitrum to base, in this, the risk is taken by the solver. Basically, solver is providing the liquidity to the users. Okay. That means the settlement to the destination chain is not done by the user itself. The liquidity is provided by the solver, and then the complex part, that is the settlement or equalizing of the asset that they have given to the solver, that can be done later part. And if you see different protocol have a different logic to settle it. For example, I'm not very sure, but CowSwap, one of the things that CowSwap do is uh, instead of settling to the destination chain, if they find something, for example, one user wanted to send 1 ETH from Arbitrum to base, while the another user wanted to send 1 ETH from base to Arbitrum, right? So rather than doing the exact settling of asset, what they do is they initiate the P2P transactions over there. Okay. So that basically, resolves the thing. Again, other protocol have other mechanism to fix the liquidity and everything. But in short, coming back to your question, can open intent framework do cross-chain swap? The answer is yes. And the risk is taken by the solver. Instead of settling the asset to the destination change, the solver basically provides the liquidity to the users.
Thank you so much, Pranshu. And also maybe can open intent framework be used for like for cross-chain contract calls maybe?
What do you mean by cross-chain contract call? So basically, right now, if you see, these are majorly, using the token swap, votes, or a few things. For example, if you go to the intent framework and interface, where we are. Okay, I am in the TypeScript thing. Sorry. If you go to the Solidity part, SRC, ERC-7683, the last thing, this order data, if you see, right? Here you can provide the token amounts, the fees and maybe the votes and everything. So this specific parameter can be used to do that. But of course, if you are talking about the contract calls in terms of token transfer, votes, or like a few of the things, so staking, then yes, yeah.
More like generic calls, if you know.
Are you talking about the account abstraction or something, like some specific functions?
Whatever other contract call. So for example, you have a contract with whatever function on a chain, and you're on another chain, and you want to call that remote contract.
No, no. So basically, if you see right now, what we are doing with OIF or ERC-7683 is we are easing the process of assets transfer, or
Okay.
managing the assets.
Okay, got it.
Because solvers have their own liquidity. For example, solvers have 1,000 ETH and 1,000 DAI. So now what we are doing is, as a user, we are transferring 1 ETH from Arbitrum to Base, right? So instead, like settlement will take, finality will take 10-15 minutes or like 1-2 minutes, whatever it is, right? Instead of this, solver will say, I already have those liquidity. Don't wait for the finalization and everything. I'll give it to you. You just pay me an extra fee. For example, 0.3% or something. The slippage that we say. Yeah.
Okay, cool. And another question is, you said there's this front-end component. So there are 3 components, and one of the components is the front-end. So I assume that front-end is used to display the registry of all the intents. So let's say I'm a solver. Where do I find all the intents that I can solve?
Yeah. So if you see right now with OIF, what they did is, of course, like, we were talking about the intent and solver a lot, right? Now, as an end user, you also wanted to see, like, how it can be implemented, how it can be used, or like, how it actually functions, right? So for that, they also have provided as the UI, this whole framework or like UI thing. So this open app.openintent.xyz, this is basically the part of that UI thing. So here you can basically clone and directly, consume this whole thing, like how it basically works, or like, how it basically, things works. You can see by, playing with that UI. So that's why, like, this is the hyper lane wrap root UI template that they have provided.
Okay, so this is basically a template, but I was more interested in let's say I want to be a solver. So what does the protocol, or what does the framework specify in respect to how solvers find out what intents are there in the world?
Okay, got it.
So
Got
I
it.
want to go
I
in one
think
place and find all the intents in one place, so that I don't have to query multiple chains or whatever.
got it. So I think in that case, if you see, like, even when we have done this transaction, so when we have provided the intent, we have signed or we have initiated the transaction on chain, right? So that basically emits the event. That event is basically listened by all the solvers, and through which they came to know, okay, there is an intent of this and this. Now, of course, like, as per the auction or anything, they can, do the things like whether they wanted to take part. For example, this is a very great example. Okay, user submits the intent expression, format of intent. Now there can be 2 use cases. One is that we are talking the standard 7683, right? Second is the custom format that is not a part of 7683. Now in both the cases, intent is received by protocol because it basically emits the event, right? Now there is an auction process that will happens for the solvers because they have got this intent. Now this auction process happens for the solver. if they are not, a part of this standard, then there can be an high fixed cost complexity staking requirement. But of course, if it's a part of a standard ERC-7683, then the solver selection will take place. So they will place a bid, the auction thing, and once the winning solver is selected, now two things they'll check, right? For example, the intent is for, let's say, 1 ETH to fulfill the 1 ETH. Now in the auction, the winning solver might just have 0.8 ETH. So what they'll say is if they have sufficient resources to fulfill the request. If yes, then single solver execute the transaction and end of it, right? But if no, then it trigger the solver collaboration. That is, multiple solver can come to fulfill that one request, right? And then of course, it's a bit complex. Then there are like few different use cases how you can fulfill all those things. But finally, like once that is done, then you can execute the intent transaction. And finally, as we say, the intent settlement over here.
Okay, got it. Thanks. So basically, I'll go to the framework, to the protocol, and I'll query or register myself as a solver on the protocol, something like that. Because
You can, yeah. So if you wanted to become a solver, you can basically use this. So they have created this whole directory of solver, right? So it is basically like, doing all these things, like checking the events or everything. For example, I can show you maybe, okay, no. Yeah, I was working on one of the solvers, but yeah. So in short, basically, like, the whole idea of solver is they basically listen to those events and everything. But if you actually wanted to do it in the right way with the OIF, you can go to this directory, you can go to the solver, try to clone this, and you can run this solver thing. So they have provided the whole, template for this. And you can see like, this will have all this, validate the solver name, create everything you can see over here.
Okay, got it.
Yeah.
Cool. Other questions? Maybe until we have other questions, let's go. It's the Pope time, or POP time. So I'll share my screen. So maybe Pranshu, if you could answer yours for a while.
Yeah, definitely.
Okay, cool. Thanks. Yeah, so guys, go ahead and scan the POAP. And again, as I mentioned at the beginning, one POAP is 25% conference ticket discount. And you can collect up to 4 POAPs. And if you collect 4, you get a free ticket to the ETHCluj conference at the end of June.
Sorry,
And,
just stepping in here, Alex. Actually, you can collect way more than up to 4. You can collect as many as you want. Sorry to cut in. So guys, we're gonna do like several meetups up to ETHCluj. Nice work, Pranshu. I see you collected yours. We're gonna do like, this is like an open for all learning initiative that we're conducting together with the ETHCluj team. So what we want to do is make sure that this very useful content and these meetups reach as many people as possible. People who are interested in finding out more about the Ethereum ecosystem, learning bits of information, and maybe getting the appetite to dig for some more. So anybody that wants to join, obviously the meeting, it's free for all. Please join online, make sure to spread the word, and every meetup we're going to host, we're going to have a different POAP for each one that all of you can collect. And if you collect, well, this is a 25% discount for each POAP collected. You can stack them up and have like a completely free ticket to ETHCluj, which is happening this year in June between 26 to 28, right? So yeah, looking forward to seeing as many of you over there. we're waiting for you with open arms. So join in, keep on learning, join our meetups, and get in touch with us as well.
Cool. Any other questions, or we can wrap up? Okay, cool. So thanks everyone for joining. We'll post the recording. We'll upload it to YouTube, and you'll have the link in the on our meetup page. You already have Pranshru's slides in there, so video coming too. Okay, guys. See you at the next one. Bye bye. Have a great day.
Guys, thanks, Pranshu.
Thank you so much, everyone,
Bye, guys.
for tuning in. Thanks, Alex. Thanks, Ronan.
Thank you.
Have a good day.